Alrighty, in this video we are going to be doing applications of implicit differentiation. So all of these tangent line equations and all of that good stuff. So for number 17, we have x squared plus 2x plus y to the fourth plus 4y is equal to 5. And for part A, it says write an equation for the line tangent to the curve at the point -2, 1. And part B says find the points on the implicit graph where the tangent line is vertical. All right, so what we're going to do is go ahead and take the derivative of our implicit function for part A. That's going to be 2x plus 2 plus 4y to the third y prime plus 4y prime is equal to 0. Then we're going to solve for y prime. So what I'm going to do is probably move the 2x and the 2. I'm going to factor out a y prime. And then I'm going to divide by 4y cubed plus 4. That's going to give me my y prime. At this point, we want to find the slope at the point -2, 1. So we are going to plug in -2 and +1. But before we do that, I'm going to go ahead and simplify this a little bit just so that it is a little bit cleaner. With the -2 and the 4, I'm going to simplify that to be 1 and 2. All right, and then I'm going to plug in -2 and +1. If I do that, I'm going to get, let's see. Oh, that should be a -2, huh? Oopsies. So this should be a plus. That should give us -1, 4, 1/4. So my slope at the point -2, 1 is 1/4, which means that my equation of the tangent line is y minus 1 is equal to 1/4 x plus 2. Part B says find the points on the implicit graph where the tangent line is vertical. So remember that if we have a vertical tangent line, this is when my derivative is undefined, aka my denominator is 0. So here, this is going to be y to the third plus 1 is equal to 0. If I were to factor this, we're going to get something like this. And then we don't really care about the y squared minus y plus 1 part. The only thing we really care about is the y plus 1 part. That's just going to be -1. So this tells me that my y value is going to be -1. So I'm going to have something comma -1. Well, to find my x value, we are going to plug in -1 into my implicit function and then see where that gives us. So x squared plus 2x plus -1 to the fourth plus 4 -1 is equal to 5. X squared plus 2x plus 1 minus 4 is equal to 5. 1 minus 4 is -3. And then I'm going to move the 5 over so that this is technically -8. So x squared plus 2x minus 8 is equal to 0. Factor that. This is going to give me x is equal to -4 and x is equal to 2. So my final answer would be 2, -1 and -4, -1. So I'm going to show you what this implicit graph looks like, and we'll see that at 2, -1 and at -4, -1, our tangent line is going to be vertical. All right, so we have x squared plus 2x plus y to the fourth plus 4y is equal to 5. And as you guys can see here at 2, -1, right here we have a vertical tangent line and a vertical tangent line at -4, -1. Also, if we were to look at part A again, where we wanted to find the tangent line at -2, 1, if I were to do that, y minus 1 is equal to 1/4 x minus 2, not minus 2, plus 2 You can see that my tangent line fits right there. So we know that that works for part A. All right, number 18. It says, find the equation of the tangent line to the graph of y minus 2 squared is equal to x minus 3 at x is equal to 4. And I give you a hint that there are 2. Well, we are only given the x value, so we kind of need to find out the y value. So here, if x is equal to 4, then we have y minus 2 squared is equal to 4 times 1, or 4. Y minus 2 squared is equal to plus or minus 2. Oops, take the square root, plus or minus 2. So y is equal to 2 plus or minus 2, which means that y can either be 4 or y can either be 0. So I have at 4, 0, and then we have another one at 4, 4. Well, we gotta find the derivative first, so let's go ahead and take the derivative of that. This is gonna be 2, y minus 2, and then if I were to use chain, the derivative of y with respect to x is going to be dy dx, or y prime. And then if I take the derivative of 4 times x minus 3, that's just going to be 4. So then y prime is equal to 4 over 2, y minus 2. I'm going to simplify that a little bit. So y is going to be 2 over y minus 2. And then if I were to plug in 0 for 0, I'm going to get 2 over 0 minus 2, or a slope of negative 1. So I have y minus 0 is equal to negative 1, x minus 4. If I were to do 4, I'm going to get 2 over 2, or 1. So I have y minus 4 is equal to 1, x minus 4 as my two equations. For number 20, we want to find the graph of f of x is equal to p over the square root of x plus q times the square root of x. And it has a horizontal tangent line at the points 4, 12. So I know two things. I have a point 4, 12, and I have a horizontal tangent line. If I have a horizontal tangent line, this means that I have a derivative at 4 being 0. So this means that I'm going to have 4, 0 as a point on my derivative function. So if I were to think about how to find the derivative of f of x is equal to this lovely thing right here, I'm going to go ahead and probably move the x to the top. And then take the derivative of that. It's going to be negative 1/2 px to the negative 3/2. I'm going to simplify that so that I have negative 1/2, well, p over 2, and then I have the cube root of x squared. And I already know that the derivative of the square root of x is just q 2 root x right here. That is going to represent my derivative. All right, now once I do that, I know that I have the coordinate 4, 0, so I'm just going to plug in 4, 0. Negative p, 2. If I were to plug in 4 here, wait, the other way around, since it's 2/3, 3 over 2. If I were to plug in 4 here, the square root of 4 is 2, 2 to the power is 8, so that's going to give me 8. And then if I were to plug in 4 here also, that's going to be 2. So I'm going to have 4 here and 16 here. Once again, I'm also going to plug in 4, 12 into my original function. So that's going to give me 12 is equal to p over 2 plus q2q. Notice how I have a systems of equation now, because I have my equation in red and my equation in green. And what I'm going to do is try to use elimination of some sort. So what I'm going to do here is multiply everything by the bottom one by, let's see, eight. Let's do -8. And the reason why I want to do -8 is because I'm going to eliminate the 2q right here. So if I do that, I'm going to get, let's see, p over 2, and then a minus 2q is equal to 0. 12 is equal to p over 2 plus 2q. If I were to add that, I'm going to get 12 is equal to p. Crazy. Once I get that, I'm just going to plug in 12 into one of the equation. It doesn't really matter at this point. I'm going to plug it into the top one. So I have 12 is equal to 6 plus 2q, since 12 divided by 2 is 6. I'm going to subtract 6, so 6 is equal to 2q, and q is equal to 3, which means that q is 3 and p is 12, such that I have a horizontal tangent line at 4, 12. All right, same thing for number 22. We're going to look at another application where we have a tangent line to the graph has a y-intercept of 4, and we want to find the slope of this line. So we have f of x being 2 ln of x, which means my derivative is just 2 over x, aka this is my slope. Now, I know that my tangent line equation has a y-intercept of 4. So thinking about this, I know that I have y is equal to mx plus b. And I know that my b value is going to be 4. And my slope, aka my m, is going to be 2 over x. So now I have y is equal to 2 over x, aka my slope, times x plus 4. Well, notice how my x's cancel out. So now I have y is equal to 6. Okay, but that's not really going to give me a lot. What I do need to know, I kind of need to know what x is. So I know that y is 6, but in order to get x, I'm going to have to solve. So I have 6 is equal to 2 ln of x. 3 is equal to ln of x, which means that x is going to be e to the 3rd power. Now, we're getting somewhere because I know that x is e to the 3rd power, and I know that my derivative is 2 over x. So now, I just got to find the derivative of this at e to the 3rd. Just plug it in. So I get 2 over e to the 3rd, or 2e to the -3. Fun problems.